Rome. 50,000 people are screaming. Below them, hidden beneath wooden planks and sand, something moves in the dark. Cages rattle, pulleys creak. A trapdoor snaps open, and a fully armed gladiator erupts into the light, as if the earth itself just decided to fight. How did an ancient civilization, without steel cranes, without electric motors, without computer simulations, build a machine this complex? Because that's what the Colosseum really was. Not just an arena, a machine. And today we decode the crazy engineering behind it. The real story that most history books barely touch. When the Colosseum was completed under Emperor Titus, it became the largest amphitheater ever built. 48 meters height, 189 meters length, and capacity up to 50,000 to 70,000 spectators. That's a modern football stadium, built nearly 2,000 years ago. But the insanity isn't just its size, it's the precision. The structure is an ellipse, not a circle, not a random shape. An engineered ellipse designed to optimize sight lines and structural load distribution. Every spectator had a clear view, no columns blocking vision. How do you support tens of thousands of tons of stone without reinforced concrete? The Romans solved it with geometry. The Colosseum is made from travertine limestone, tough stone, brick, and something revolutionary, Roman concrete. Unlike modern Portland cement, Roman concrete used volcanic ash, pozzolana, which chemically reacted with lime and water to create an ultra-durable compound. Modern studies show Roman marine concrete actually strengthens over time due to crystalline growth. The Colosseum wasn't just built to last decades, it was built to survive centuries, and it did. Earthquakes hit Rome repeatedly. Major ones in 847 AD and 1349 AD. Large portions collapsed, but the core structure still stands. Why? Because the Romans used a system of barrel vaults and groin vaults, interlocking arches that distributed weight outward rather than downward. This wasn't brute force engineering. This was stress redirection. Every arch transfers load into adjacent supports. Each vault reinforces the next. It's like a skeletal system made of stone. The Colosseum wasn't even the most impressive part of itself. What lay underneath was. Beneath the arena floor was a two-level subterranean complex known as the Hippodrome. Think of it as a backstage industrial facility. There were 80 vertical shafts, dozens of trapdoors, elevators powered by manpower, animal cages, mechanical winches. Historians estimate up to 60 wooden lifts could raise gladiators and animals into the arena simultaneously. Let that sink in. No hydraulics, no electricity, just ropes, pulleys, counterweights, and coordinated labor. Each elevator required teams of 8 men, operating capstans to lift platforms weighing several hundred kilograms. Imagine the synchronization. A signal is given, a trapdoor opens, a lion appears exactly on cue. This wasn't chaos, it was choreography powered by physics. The Hippodrome was essentially a Roman special effects engine. But even that isn't the wildest part. Because originally, the arena could flood. Ancient sources like Cassius Dio mention staged naval battles, naumachia, inside the Colosseum during its inaugural games. Ships fighting, water filling the arena. If true, this changes everything. But could they actually flood it? Modern archaeology suggests early versions of the Colosseum may have lacked the permanent Hippodrome structure, allowing temporary flooding systems. Rome had aqueducts capable of transporting millions of liters of water daily. Engineers likely diverted water into a sealed basin beneath the arena floor, before later retrofitting the underground machinery. If they could flood and drain the arena rapidly, that implies sophisticated hydraulic control. Controlled inflow, controlled drainage, watertight lining. Even if naval battles were smaller than described, the fact that historians recorded them tells us something critical. The Colosseum was modular, upgradable, adaptable. It evolved. Which brings us to the next engineering miracle: 50,000 people entering and exiting a stadium. No digital tickets, no LED signs, no loudspeakers. Yet ancient accounts describe crowd dispersal in minutes. How? The answer lies in vomitoria. The Colosseum had 76 numbered public entrances, plus 4 reserved for elite classes. Each ticket had a numbered section corresponding to a specific entrance and stairwell. The internal corridors formed a radial circulation system. People flowed in streams, not random crowds, controlled vectors. Modern stadium architecture still uses this Roman model because it works. But imagine the social engineering layered into the architecture. The seating was strictly hierarchical. Closest to the arena, senators. Above them, equestrians. Higher still, Roman citizens. At the top, women and the poor. The building wasn't just an arena. It was a physical map of Roman society, power embedded in stone. And then there's the roof, or rather, the retractable one. The Colosseum had a massive retractable awning called the velarium. Operated by sailors from the Roman Navy. Why sailors? Because managing vast sails under tension requires nautical expertise. Large masts were anchored around the upper perimeter. Ropes extended across the structure, supporting canvas panels that shaded spectators from the sun. Think about the forces involved. Wind load, tension stress, anchor stability. If wind speeds rose too high, the entire fabric system could become a massive sail, pulling the structure outward. So the Romans engineered reinforced anchor points directly into the stone framework. It wasn't decorative, it was structural foresight. The Colosseum wasn't just about spectacle, it was about risk management. Which leads to the final and perhaps most uncomfortable truth. The Colosseum functioned because of human labor. Tens of thousands of enslaved people, many captured after the Roman conquest of Jerusalem, were forced into construction. The amphitheater was financed largely from war spoils. The engineering marvel we admire was built on conquest economics. The Colosseum was constructed on the site of Emperor Nero's private palace, the Domus Aurea. After Nero's death, the new Flavian dynasty wanted to return land to the public. So they demolished a symbol of tyranny and replaced it with a symbol of mass entertainment. Political engineering layered onto physical engineering. The building itself was propaganda, strength, order, dominance, and it worked for centuries. So what makes the Colosseum truly crazy? It's not just the arches, not just the elevators, not just the concrete. It's integration, structural mechanics, hydraulics, logistics, crowd psychology, political messaging, all unified in a single system. Modern engineers study Roman concrete to understand its durability. Architects still model stadium flow after Roman amphitheaters, and archaeologists continue to uncover refinements we didn't expect. 2,000 years later, we're still reverse engineering Rome. That's the real story. The Colosseum wasn't primitive, it was systems engineering before the word existed. A programmable arena, a mechanical theater, a political supercomputer made of stone. When you look at the Colosseum today, it feels ancient, broken, weathered, incomplete. But imagine it in 80 AD, marble facade gleaming white, bronze statues filling the arches, painted interiors, roaring crowds, hidden machines moving beneath your feet. This wasn't just architecture, it was immersive engineering. And here's the ultimate answer to our opening question. How did they build something so advanced without modern technology? Because technology isn't electricity, it's applied knowledge. The Romans mastered materials science. They mastered force distribution. They mastered modular construction. They mastered logistics at scale. And they did it with human power, mathematics, and relentless organization. The Colosseum isn't crazy because it's big. It's crazy because it's coherent. Every component supports the next. A perfectly integrated machine built 2,000 years ago. And that's the true story behind its engineering. Not myth, not exaggeration, but calculated brilliance carved in stone.